ground rules. First of all, you are in the nerdy session. So if you don't identify as a nerd, you could quickly get to the other session. If you stay, you're a nerd, sit down. We're looking for your participation. This is a workshop, not a lecture. So you have 3 mics. The full extended team is here. It can help run mics to you if you have questions. You don't have to wait for specific question times. As long as your questions are on topic, we encourage them. I think the second is that this is a level setting material. If you've been around CESMII a while, some of it will be familiar. I didn't write new material for this session. This is to get us kind of all to the same place on some of the topics that we think a lot about, spend a lot of time on at CESMII. So if you feel like you're an expert in a topic and you have something to add to the conversation, we would welcome that. If you think I'm wrong and you want to argue with me, you could do that later over a beer. I can provide no tech support at all, but that's the Wi-Fi password, and I think it's called ORNL Visitor. So as long as there are no follow-up questions, good luck with that. I will add that it does take, like, after you join the network, you have to open a browser, agree to something, and then it takes like a full 5 minutes to get you added. So if you want to be able to Google things as we go, do that now. Again, I am not tech support. Maybe another ground rule. Obviously, there are big world events happening right now. We're just going to have a safe space here where we're not talking about those. I'm sure there's the full range of feelings represented in this room, but you've all just self-identified as nerds, so we have that as that in common. Let's just talk nerdy about manufacturing. We want to improve the state of US manufacturing. We want to do that in partnership with the rest of the globe. We do that by, in our opinion, helping manufacturers get better access to their data, turn that data into actionable information so that they can make better decisions. So that's what we're all here for. That's what we're going to focus on for the next 2.5 hours or so. They didn't schedule a break, but I'll tell you we have 3 topics. I will plan a break at the end of the first topic, which will take us through probably a good chunk of the first hour. But obviously the restrooms are there at any point if you need to step out. All right. There's me. I'm Jonathan Wise. I'm the Chief Technology Architect at CESMII. It's a fancy title, but the CESMII team's actually fairly small. We work by engaging with the manufacturing ecosystem. So vendors are represented here, and users are represented here. Researchers and academia are represented here. So my job is just to kind of look across all of those things and try to help make sure we're supporting each other and heading in the right directions. Obviously, my job is to have some opinions on what those right directions are. So a little on my background. I spent a little more than 10 years writing software as a software developer for manufacturing information systems. I worked for Rockwell Automation at the start of my career, a startup in London, Ontario, Canada called ActivePlant, which I was shocked to find a few years ago. That software is still running in major automotives. It was good software. I didn't think it was that good, but that's really cool. From there, I joined GE. The division at the time was called GE Fanuc. It was a joint venture with Fanuc. I worked on prophecy plan applications and was a part of the team kind of thinking about what they called prophecy SOA, service-oriented architecture, which was an attempt to create a platform for all manufacturing information problems. After that, I switched to a slightly different kind of career trajectory. I joined Microsoft as a developer evangelist at the dawn of this thing called the cloud. AWS had a solid lead, and Microsoft was determined to catch up with a direction that was firmly platform as a service. So my job was to go evangelize this idea to manufacturing ISVs and try to convince them to bring their software into the cloud. The approach turned out to be almost untenable. Rather than infrastructure as a service, which is put your software on a VM and put it in the cloud, it was rewrite your software to run on our fabric, and we'll take care of it. The problem was we couldn't tell you how much that was going to cost. So not only was it rewrite your software, but also prepare to pay us a bill. We'll tell you the size later. So it was a really interesting kind of pivot point where I think I learned a lot. I engaged with some of the folks in this room on exploring how that would work. I did that for about 3 years and then joined Amazon, where I worked on their IoT devices. We had a series of letter projects where I worked first as a technology evangelist, then as a technical business development manager, and finally as a product manager on these IoT devices, some of which were a success, some of which were not. I have a Fire phone still at home, and I think there were a lot of cool lessons learned from that one as well. I rejoined Rockwell prior to this role, spent about 4 years on new product initiatives. So we had this cool little incubator where we got to try out cool ideas with the deliberate intent of bringing some consumer IoT ideas into the manufacturing space, but all focused on manufacturing information. A couple of my team members are in the room. I think we actually have a mini reunion. So if you worked on Shelby or Sherlock, would you stand up? Yeah. These were, thanks guys, Jennifer, Olivia, and Dave. These were some of the origin of what we're going to talk about today. The notion that if we profile manufacturing information sources, we can load those profiles in real time and automate the collection of data and the creation of value from that data. They were early explorations. I don't think they were commercial successes, but it really was cool that Rockwell was willing to take a bet on sort of exploring what the future looked like. So some of those ideas are here. What is gratifying to see is that Rockwell's in the room, but so are many other vendors who have kind of believed in this vision that we can make it easier for manufacturers to understand what's happening in their operations. We can accelerate that effort through standardization, through taking advantage of IT technologies that maybe haven't been easily available to manufacturers, and that we can lead the way by leveraging some of the newer technologies that we harness in other spaces and make those things available to manufacturers as well. So that's what we're going to talk about today. And we kind of break this into a few different problem areas. I've listed 6, but grouped, there are actually 3 of them. So these are the 3 problem areas that we're going to address. Clicker's a little slow here. Problem number 1 is largely focused around consistency. We had the International Manufacturing X contingency here yesterday from around the world. All of them thinking about consistency in manufacturing and industrial data. I think everybody acknowledges that we have challenges here. This is problem number 1 from CESMII's perspective. Problem number 2 is identity and discoverability. If we can drive consistency through standards, how do we make sure that we can discover that data at runtime or in the supply chain as we need it? And then problem number 3 is modernizing our stacks. How do we take advantage of newer technology to make it easier to access this data? We have a couple demos kind of for each of these things, just exploring them. The demos are centered on specific technology, but what I want to call out in advance is that even though we'll be showing it in one vendor stack, any number of software vendors can implement these ideas, and lots of them are. If you're here tomorrow, we have a session we're informally calling Demo Fest, where we show a wide array of software that's taking advantage of these ideas. There'll be some main stage discussions about how the industry is heading in these directions. So although the demos are kind of narrowly focused, the ideas are broadly applicable. I want to address up front, because it's frequently discussed on social media, that protocols actually aren't the solution to any of these problems. Protocols are a fact of life. People have opinions on which protocols are good. Those opinions are valid. We can discuss them constructively, but the reality is for most manufacturers, especially in the US, they don't actually have a ton of choice about what protocol they're going to be using. The protocol came with the equipment that they got. They inherited the equipment from purchases years ago or from acquisitions. And although they can implement protocol adapters, we are dealing with homogeneous architectures that are made up of lots of different pieces, and no protocol religion is going to fix that problem. There are MQTT zealots. Maybe there are some in this room. I love MQTT. You can do really cool things with it. There are OPC UA zealots. I work closely with the OPC Foundation. You can do some cool things with that. But the reality is lots of equipment still speaks Modbus. Lots of equipment speaks CIP, Common Industrial Protocol. Lots of equipment we still connect to with an RS-232 port, or we splice some wires to figure out what the machine is doing. So this discussion is not about which protocol is best. We can have that discussion over a beer, but that is not the answer to the problems that we're discussing today. It is a fact of life that we just have to deal with. So problem number one, consistency. CESMII sponsors projects. By my count, more than 50 since I've been at CESMII. And a lot of those projects have data science bent, which is good. That's what you would expect to see. And data scientists, to a fault, would like to see some nice columnar data. They would like to see the data organized in a way that they can identify the features and try to build a model or train an algorithm to make a prediction. That makes a lot of sense. And so if I have a spreadsheet that looks like this, where I have my neatly labeled columns and rows, I have features identified, and I can start to make a prediction. Our consistency problem, and it's related to the protocol, but again, not solved by the protocol, is that none of our machines are going to give us this nice spreadsheet of values. I can't think of a single one. It's going to let me plug into it, and it's going to dump out a CSV that I can use to start training an algorithm or doing data science with. We can improve the situation with protocol adaptation. So I can connect to different machines and try to normalize the data. So it's a layer of abstraction. This is our first layer of abstraction that's present in every industrial information system, is the adaptation to the machine protocol. But even having done that, the protocol itself is going to identify the data in a different way. If I'm lucky enough to have a machine or a sensor that speaks MQTT, I might have a payload with a nice structure that includes a label that hopefully makes some sense. If I am talking to the machine by its memory location, the label for that data is a memory location and a bit offset. So that's not a label that I can use for machine learning. We solve this problem with the next layer of abstraction, which is a map. For each source, we implement a map that translates what the machine calls the value to what we desire the value to be called for our machine learning or data science exploration. We do that for each machine that we want to include in our trained model. And so we end up with multiple maps, multiple layers of abstraction. One of those layers of abstraction is commonly implemented in the PLC. The PLC can provide us drivers that allow us to talk to a variety of machines. If there aren't drivers, we can actually wire the I/O, and we can label those values with PLC tags. But don't be confused. We've just moved the problem up a layer. the PLC tag name is also arbitrary. There are standards for naming tags. ISA 88 gives you some good advice on how you should name your tags. But that implementation is done by a PLC programmer who may or may not know about ISA 88 and almost certainly wasn't designing their tag structure for the purposes of data science. They weren't labeling features, they were labeling I/O. So this abstraction that's present in many manufacturing environments, the PLC becomes the de facto proxy for the equipment that provides data that we want to start with. This abstraction is just the same problem moved up a layer, where a PLC vendor has their own software that allows you to talk to their PLCs to extract the tag names that their customers have chosen to put on the I/O that their equipment is connected to. We have not solved the problem by using a PLC. We have solved other problems by using a PLC. PLCs are very powerful for control, and you will never hear me advocate, at least not in the near future, that we should remove PLCs for control decisions. What I'm saying is that this plane is not a suitable layer of abstraction for information analysis. It is a proxy for what's below it. A useful proxy, but it's going to need another map. It's going to need somebody to translate those tag names into the neat set of features that we were hoping for when we wanted to do our data science. This is another example. DO lower deadband, so that's literally digital output. The tag name is the output. DI would be digital input. So the tag name is the PLC label for that I/O, not the data science label, not the feature name that we want for information exploration. We don't solve this problem, again, with MQTT. We might get better tag names with MQTT. We might get richer payloads by abstracting our PLC with an MQTT client that organizes that data, maybe relabels that data and puts it on a broker. We actually introduce additional problems by believing that MQTT, a protocol, is going to solve the problem. MQTT introduces an attribution challenge that we're going to talk about. That community has responded with a concept called the UNS, the Universal Namespace, that can help address it. We're going to talk about that as well. But let's be clear that MQTT does not solve this problem because its labels are also arbitrary. It actually just moves the problem up another layer, unless you are extremely disciplined in your MQTT implementation. I would argue that nobody is, because there's an important discipline that largely that community has been slower to adopt. And we're going to talk about that as well. I guess this is the illustration for this. So I chose not to stand in front of my podium to be more central. That means I don't know what slide's coming next. So I know roughly. I might get a little ahead of myself. I apologize. This is the unified data problem. Who is doing the unification? We have a proposal to fix that. We are not alone in that proposal. Our international colleagues are actually well ahead of us in solving this unification challenge. But the unification challenge is the same problem moved up another layer. When we talk about this labeling of data, this identification of features, this mapping to the data sources, we use the word profile or smart manufacturing profile. I'll talk on stage tomorrow about profiles and how they have many different names. Our name for a profile in its first part describes the data and provides a document format that allows us to standardize the labels for that data. That's what a profile is. You could also call a profile a template, and in fact, many systems it's called a template. You could also call a profile a model. In some systems it's called a model. I'm okay with all of those words. I may accidentally use them interchangeably. There's probably subtle differences between them that we can debate. But for the purposes of this conversation, profiles in their first part is the description of the data using the desired terminology. This desired terminology we would call the semantics. If I say temperature, what temperature do I mean? If I say temperature, am I spelling out temperature as a complete word, or am I abbreviating it to temp? If I say speed, what speed do I mean? What am I measuring that speed in? This is the function of the profile. It is to provide a map. We've already talked about multiple maps, but an authoritative map that can be used for any data source. You can map Modbus directly to a profile. There's a complementary technology called Web of Things that allows us to do that. You can map a profile to the PLC tag names. You can map a profile to an MQTT topic or a topic member. You can map a profile to a tag in a historian that is a proxy for multiple data sources on your plant floor. The profile is agnostic to how you get the data. It provides the definition of what that data means. And we call it authoritative because it doesn't live in any one system. It can be ingested into multiple systems so that they can follow the rules of the profile, so that they can adhere to the profile. But no vendor, no system is the owner of the profile. Profiles are chosen by the ecosystem that wants to implement them. That ecosystem is in layers. Those layers need to include standards bodies, and we'll get to that as well. But this profile document is the rules for understanding the data, regardless of how you acquire that data. Profiles are such an important concept that we're spending until our break on this. And we have a demonstration we would like to show maybe in a minute. But I want to pause here to talk about profiles in as much detail as we need to. How many people in the room were familiar with profiles before you got here? Okay. How many people who didn't raise your hands feel like you have a handle on what profiles are now? Okay. So let's do questions. I'm going to stop talking. Have we moved? Yeah. Sorry. So one more ground rule. There are people on the recording and remote. So I want your questions, but we have to get you a mic. So go ahead.
So have you essentially moved the problem to some other stakeholder now? Who populates these profiles? Who maintains this metadata and so on and so forth? So can you comment on that?
Yeah. Yeah. Really good question. Just leave that there in case anybody else needs it. A profile being external to any one system might imply that there is no one that owns that thing. If no one owns it, or if everyone owns it, or everyone uses it, then no one owns it. This is a lesson learned for me personally in those 50 CESMII projects. Technology change is not just about providing tools to manufacturers. It is about changing their culture. One of the things that needs to be a part of any industrial transformation or Industry 4.0 or smart manufacturing project is that there needs to be, I hate to say the word, a governance team or a data integrity team that takes responsibility for this and is given the authority to define these things and oversee the adoption of them. It doesn't mean that there can't be citizen development. It doesn't mean there can't be experiments and ideation and exploration. In fact, one of the tenets of the profile concept is extension. And I think we'll talk about that. The ability to specialize a profile for different purposes. But just like the unified namespace folks would like to believe, somebody or some group of people has to take responsibility for data integrity. Our data can't continue to be a mess. And this is we believe a profile is a useful tool for that, but this is more of a cultural change that needs to happen. And so there are teams in this room who have put together kind of cross-discipline groups, IT, OT, operations, and software development, whatever you want to call it, who work together to create these internal standards and should be aware of the external standards bodies that are working on kind of the same problem space. And they should be given the authority to select the profiles and ensure their adoption throughout. Where you adopt is going to differ depending on kind of your systems architecture, what other tools that you have available to you. You can adopt the profile at the HMI SCADA level. That may be the earliest opportunity for many folks. You could adopt the profile at your UNS. That can work for many folks. You could adopt the profile at a higher level system, so the data is a mess, but by the time it gets to our data lake, it is profiled. There are pros and cons to different approaches, but there's an evolving set of tools that allow you to enforce your internal standards at the right level for your organization. And that's an exercise that should happen. Yeah, question at the back. You're on.
Monica with TMAC. So I'm new to this profile knowledge, but being boots on the ground with the manufacturers in Texas, a lot of what we're seeing is our small manufacturers outsource their IT department. And when we try to implement and or try to support them, if the IT group that they have consulted with says no, and they give them this, you know, far-fetched reason why and how it's going to cause their whole production to shut down, and you know, it's an automatic no.
Right.
So what is CESMII doing to communicate this and roll it out in a way that the MEPs can then support our small to medium-sized manufacturers? Maybe you don't have an answer, but I mean, this makes perfect sense. But understanding their data, some of them are not even there yet.
Yeah, I have technical thoughts, but I know there are practitioners in the room, so I want to open that question up to everyone. Sometimes you don't fully control your data destiny, so how do you deal with that? Yeah.
Yeah, I may have a follow-up question going to pretty much the same point here. Jan from Lockheed Martin. Shouldn't the profile eventually be something I can put in my statement of work? When I order a machine, should I be able to say, add machinery profile per whatever it is, so that I get one and the machine communicates one upon request? Isn't that kind of the...
Hold on, Eric. I know who needs to answer that question, but I'll give you it. Gentlemen.
Hi, how you doing? My name is John Wenthes, Garen Remenschneider. We're from Anderson Corporation, Anderson Windows. So our approach has been to leverage the OPC UA job model as a structure for the equipment. So as we purchase equipment or write purchase orders, we're now specifying in the purchase specification to say thou shalt follow the OPC UA job model. That really becomes the core independent communication mechanism, and it's working really well for especially our equipment suppliers in Europe, because as he mentioned, right, especially in Germany, where a lot of our equipment's coming from these days, they're much further ahead. So those kind of conversations in Germany and Italy are much more well received, and it's able to give us a really that independent standard that we can rely on, so that it's not a personal preference by the equipment vendor or by the company. We actually say, hey, here's the model, and we've found especially the job model works very well for us because it maps out what material comes in, what material comes out. Even in a 100% configured order business like ours, we're able to map all properties that we can use from our engineering data to map right to the equipment and have that common set of communication parameters. So that's we're just early in this conversation, but it's going very well for us because we historically, we've run into exactly that problem where every vendor, every partner wants to do their own way. So this is our attempt to just try to standardize that. So,
and to literally say to their vendors, if we're going to buy from you, you need to do this. Thanks. Go ahead, Eric.
Eric Barnson from Microsoft. So I've been working on profiles for many, many years. Obviously, they're both based on OPC UA technology. So I congratulate the last statement. And it is exactly like that. You can't just make OPC UA a checkbox. It's a lot more complicated than that. You need to specify what profiles in OPC UA you want. And to Jonathan's point, if the vendor doesn't support it and they say, no, we have this custom solution that's better, you say, well, then you don't get the contract. It's that simple. And again, it's all about education, understanding what profiles are available, which ones fit to your industry, and then pick one. I'm working, just one more point, I'm actually working with many American manufacturers now that have made that choice and have picked a profile and said, this is what we're going to standardize on. Now, it's a journey, and it requires a lot of education, but that's what we're here for.
So I want to go back to the original question and just acknowledge that if you're the size of Anderson Windows or Lockheed Martin, maybe you have the clout to tell your vendors it will be this way. And if you're working with the MEP network, you might not be that size. Yeah. And I don't have a great answer to that. I think it is a true statement that small and medium manufacturers are largely at the whim of the vendors that will work with them. And it's often the case that the big vendors won't call on a manufacturer that has less than 5 manufacturing facilities. It's just not worth the effort for them. So I think there's maybe 2 incomplete answers to that. One is CESMII works with the MEP network. So you can bring us in to help those projects maybe move in the right direction. The other is, I see your question. The other is that this is an ecosystem play. I'm maybe not a believer in trickle-down economics, but trickle-down technology is a reality that as the state of the art improves, it kind of forces everyone else to eventually catch up. So we are seeing the ecosystem evolve. We are seeing smaller vendors, smaller players beginning to pay attention to these things, trying to figure out how to do it right. There is good dialogue on social media, maybe not always 100% right, but in like thrusting in the right direction that we need to do a better job of this. So I think there is hope for the small to mediums, but please do engage with the team here if we can help. There was another question back there.
Thanks, Jonathan. Just one overarching.
Yeah.
So you impose the profile on the vendor. Over your experience, time to market, does it put a stumbling block to the whole ingenuity, getting it done?
Yeah.
And I mean, time is money now. What has your experience been when you tell a person to do this? Is this a cog in the wheel, or is this, I know eventually it makes sense.
Yeah.
But when you want to have your idea going out and being able to express it in no time, and you're telling me, okay, now I have to do this profile, what is the net result to the market?
There was a great quote from a colleague when I worked at Rockwell Automation. Any technology problem can be solved with another layer of abstraction. We've already talked about multiple layers of abstraction here. What you're really talking about is a greenfield versus brownfield problem. We have high hopes, and we have vendors pushing for, or manufacturers pushing for vendors to ship machines with the server on board that hopefully complies with one or more profiles so that its data can be understood by the time it arrives, but that's going to be a while, right? Meanwhile, we have lots and lots and lots of equipment that is not like that. We can't just buy new equipment because we want better software in it. We need to adapt to it. And Eric is chomping at the bit to talk about one of those adaptations.
Right. So in my experience, yes, it's true that you will slow down your integration partner because they need to understand this profile technology. However, in my experience, all subsequent integration projects go quicker because then you have that compatibility layer already built in. So you're investing into the future. right?
The profile is the description of the destination that you want to get to. And maybe you can get there by buying new equipment that's already there, but maybe you're going to use that as the target that you're going to deploy existing technology towards, right? The profile tells me that I need these values and my current equipment does not have that instrumentation. So I'm going to add some sensors to comply with the profile, to fulfill the profile against my brownfield equipment. I'm going to put an MQTT adapter and deploy the profile into my unified namespace and translate into the profile. The profile, even in brownfield cases, is a useful banner that all efforts can push towards. Doug Lawson. Pass that back.
Jonathan, one of the things that's interesting is CESMII has created an awareness of profiles, and we almost have too many of them at this point. There's approximately 200 in the marketplace, and I anticipate...
And they're not all good.
And they're not all good. And that number is going to grow rapidly at this point with the adoption by more and more vendors of the standards. More people are rolling their own.
Yeah.
And I'm expecting a step increase with the alignment that is occurring with our friends in Germany who have the asset administration shell, which will now be another rich source of profiles. What can CESMII do to help us navigate this wild, woolly world of lots and lots of profiles? Because it's not difficult, it's not easy to choose the right ones.
Thank you for the leading question. That's a good one. So if we've got a base level of comfort on what we're trying to accomplish with profiles, it's time to add some players to the mix. So first of all, the language that we have chosen for profiles is OPC UA Part 5. I said at the beginning, and I maintain that this is not a protocol discussion. UA in OPC UA stands for Unified Architecture. There are 17 base parts, 19 base parts, right? They're trying to unify everything. Some parts are maybe better than others. For profiles, we are using OPC UA Part 5 optionally with the other parts. So if you have an OPC stack and you're all in on OPC UA, that's great. You can adopt all 19 parts. If you're like, we don't like OPC, we want to go MQTT because we have that religion, that's fine because you can still use OPC UA Part 5. Incidentally, you can also use OPC over MQTT, but that's another discussion. I knew if I didn't, you would. Part 5 is an information modeling language. It is serialized to a format called the NodeSet2 XML format. It is not a pretty format to read. I call it the stages of grief in kind of understanding how a node set is structured. But it is understandable. A human can understand it. And importantly, software can understand it. The node set serialization or deserialization, I always get them backwards, can be turned into a class in Java or in C#. It can be turned into JSON if that's kind of the environment that you're in. Anything can read this node set XML. And importantly, nobody has to pay a license fee to do it. So it's kind of like HTML in that everybody can use it. It's got warts, but it's open and everybody can use that format. Also importantly, for our academic folks and our researchers, I can take a UML diagram and I can serialize that into a node set, maybe multiple node sets. But I get full fidelity in a rich theoretical modeling environment that then I can take and crystallize into a node set or collection of node sets that I can actually implement in an industrial world. It allows me to take my theoretical models and distill them into something that I can implement in a manufacturing environment. It's not perfect, but it's the best that we've got that everybody can use, and it's remarkably capable. So a profile is an OPC UA node set. It doesn't mean you have to use OPC UA, but we are using that part. And we have fairly global agreement to use the UA node set format for modeling. The question at the back.
Yeah, with regard to standardization, just a question. So I'm tracking with the concept of the profile. In the last slide that you illustrated, there's also a hierarchy implied yeah, in the middle there. Yeah. So wondering what, maybe if we can expound on the value, is there a value to standardize that hierarchy? And then what is the driver or the standardization approach for the hierarchical structure of the nodes that reference the profiles?
That's a great call out, almost a leading question. We are going to spend a whole section on that hierarchy. I'll say simply for this part that the profile or collection of profiles help define the nodes that go into that hierarchy. You could actually use a profile to define the entire hierarchy. You would probably feel pretty limited at that point. But at a minimum, profiles define the nodes that go into it. And then we'll talk much more about hierarchies in the next topic.
Can I just answer the standardization question? So once a profile gets broad adoption in the industry, usually what happens is that the people using it get together, they form a working group inside the OPC Foundation, and then standardize that profile and becomes part of the OPC UA standard. As
now you're jumping the gun.
Companion specification, right? That I like to jump the gun. Yeah. So there is a process to do that, but you don't have to go down that path just to use it. You can use it yourself, and then it becomes your profile.
So let's talk about some of those groups. UA node sets, what we call profiles, have actually predate CESMII. The concept and probably the format, at least since 2011. But there were a few problems. Doug identified one of them. How do you know which profiles to use and whether they're good ones or not? Who's allowed to make profiles? What do we do with, how do we deal with proliferation? We actually had a prerequisite problem that we wanted to address first, which was the availability of these profiles. So with availability comes all of the painful things that Doug wants me to talk about that I promised I will. But the first problem was nobody knew that these things existed. So when I joined CESMII, there were about 60 published. These 60 were created by professional working groups. In the OPC Foundation, it actually doesn't take much to create a working group. If you can find a few people who agree that this is a problem, they will support you in standing up a working group and creating a companion specification. A companion specification for an information model has two deliverables. One is a document, a human readable document. They've got a Word template for it, and you can publish it in Word or PDF, and it describes your information model. And then the other required deliverable is the node set to XML. About 60 of these things existed when we started. They were in an obscure GitHub repo that Randy Armstrong knew how to find and nobody else did. And so there was zero adoption, or almost zero adoption, because nobody knew where these things were. We, along with these other organizations, agreed that this concept was good, that we wanted to get people ideating on profiles, and to do that, people needed to be able to find them and learn about them. So we created a working group, a joint working group with the OPC Foundation. Eric and I were chairs of that group to create a cloud library. The cloud library has a user front end where you can search for profiles, but it also has two APIs where your software can search for profiles. You can search for profiles over REST or over GraphQL. Given a search term, it will tell you what published profiles might be worth looking at. Our search actually isn't great. Even though we had Google on board, they maybe could have helped us a little more with better search. So that's something that needs to be done. But we actually have now flipped to the opposite problem, where now that there's a way to search for and programmatically fetch these profiles, we're starting to veer towards too many with some overlap. These are some of the inputs for profiles, which is great. This is a great next problem to have. from a small set of profiles nobody knew about to lots of people thinking about these profiles, publishing profiles, and now maybe we have too many and some of them do the same thing as others, and it's hard to tell which ones are the right ones. There is one professional group in Europe, the VDMA. Somehow that acronym expands in English to European Machine Builders Association. German. Yeah, of course, in German. Thank you. Yeah. Thank you. They have published a number of these professional profiles. They are machine builders who put working groups together. They know their machines very well, and they define a profile for their machines, and they publish it via this formal method. They have well-written companion specifications. They have professionally created node sets, and they are published to multiple cloud libraries where you can find them. VDMA, like any organization, has been through a couple of different eras and evolved in their thinking of how to create profiles. So there are versions coming that supplant prior versions, and it can be hard to know which ones to pick. There was a direction that maybe the whole computer science world is kind of moving through right now, where we were primarily thinking about inheritance, profiles derived from one another, and now we're thinking more about composition. Profiles are Lego blocks that we put together depending on our needs. So there's a bit of a refactoring happening where we're thinking about those Lego blocks as capabilities or identification. The job control that Anderson Windows mentioned and that they're spending a lot of time on is a capability profile that any number of machines can actually contribute to. So it's not a profile of the whole machine. It doesn't describe all of the data of the machine. But if you connect to that machine and can identify that that profile exists, you can understand what job that machine is participating in, what materials it's consuming for that job, what materials it's going to output. And so you can begin to assemble a hierarchy that includes these nodes that are contributing to a job, to building something. So yeah, profiles are evolving. Smart people are thinking about them, and then smart people are going back and thinking about the things they thought about 11 years ago and rethinking about them. And I think our next problem, now that we have lots of profiles and lots of people thinking about them, is how do we help people know which profiles are the right ones to choose? Right now, that's pretty organic. So again, I'll extend the invitation to connect with CESMII. If we don't know the answer, we talk regularly with our friends in Europe who are probably a little ahead of us on this and can provide you some input. If we can't provide input, maybe we can do a handoff to somebody who can. But this engagement is constructive. This moving towards kind of universal standardization doesn't mean everybody's manufacturing process is standardized, but it moves us towards if I have a common language for describing a job or a common language for identifying a machine, then I increase the odds that I could swap machines or I could swap supply chain participants if I have supply chain constraints, that I could resolve maintenance issues more easily by having a standard for how those issues are described. So this is what we're moving towards next. Go ahead.
So just one additional comment. So there's also a harmonization working group inside the OPC Foundation where you can contact them if you find that there's two different things that appear to be doing the same thing in two different profiles. Then they will sort out basically which one wins and consolidate accordingly. So that also exists specifically because creating a profile is supposed to be a free and natural process of industry experts, and it's impossible. I mean, there's over 300 companies alone in the VDMA working on profiles, or 600, I think it is. It's a credible amount of companies anyway involved. It's very hard to consolidate and harmonize them all. So that's why this working group exists. So if you find that something is double standardized, that you can contact them and they will sort it out, or they will help you sort it out.
As an example of kind of this creative, constructive process that needs to move towards harmonization, you are going to see some CNCs on your tour today. We are going to do some demos around CNCs, common piece of manufacturing equipment. We found that we had 3 or 4 projects that we had sponsored that were all trying to create a profile for CNCs. Each of them kind of going off in their own direction. So we pulled together an internal harmonization group where we looked at the existing published CNC profiles. We looked at the needs of each of the members and created a harmonized CNC-based profile, which was the subset, the building block that CESMII members needed of the standard that they could all implement in their projects to harmonize the profile for CNCs there. The reality is still messy, but this is a constructive messy. This is a collaborative messy where we're learning together to build a discipline that we have never, ever had in this space. There are so many analogies to other spaces. They might not call them profiles. In the early days of modern computer science, we called them objects. These objects had classes that they derived from. And even though we're sort of moving beyond object orientation and lots of programming problems, it is this object-based approach has benefited IT software development since I started coding in the 90s. This de facto understanding of objects deriving from definitions and having instances that were discoverable in modern software systems might be a new concept here in manufacturing, but is a 40-year-old concept in computer science that we're long overdue to adopt. This is an example of a professional working group around robotics. This one's from the VDMA. This one's actually a little bit dated and is due for a refactoring, but this is kind of how they think of breaking an information model down. Yeah, please.
Well, just some lessons learned because we're in the middle of this exact conversation right now. You got 2 different viewpoints of the world. One, you have the manufacturer that has to get information to the equipment. We buy a lot of CNC equipment. Okay, we buy a lot of CNC equipment that our first problem though from a manufacturing equipment is getting orders to the CNC equipment. So there's the order job perspective, and then there's the working models looking from the machine up, right? How does the machine expose what it's doing, right? But there's always these 2 different worlds of perspective. For us, we're pushing, number one, the first thing we're pushing is standardize so we can tell you what to do. And that's the job model. The second push we'll do though eventually is say, we know you're a CNC. We want you to start following a standard so that you can provide information to us, right? So, but it's an evolution to just have a conversation with these vendors because most of them are not, especially in the US here, and even as we're starting to talk to even the ones that are heavily involved with Germany and in Italy right there, they know of it, but they're not necessarily, they haven't been actually pushed to do it. So the other 2 words of advice I'll give you, have in the middle of it is there's 2 partners in Europe that have been instrumental in helping us help work with these partners. There's a company by the name of Process and Unified Automation. Both of those companies provide standard SDKs. One provides a Java SDK, one provides a .NET SDK. So we're at the point now where we can give these vendors an entire example of a profile. In our case, our profile is the job model. So they're saying, well, how the heck do we get started? Here's a working model that you can start from that you can plug on top of your equipment. That's been incredibly instrumental for us to get these vendors there. So having a partner like those 2 companies that they can work with, and they're in, and they're very familiar with these models and actually get them to work. It's beyond just the theory. They actually are writing the SDKs and, both in .NET and Java. So that's been, and obviously working with CESMII as the first step of, hey, what model should we use? And then it's like, how do you actually do it, right? And that's where these companies that offer those SDKs have been incredibly instrumental. So that's just been our experience. Again, when you talk about these profiles, you can either look look at it from the bottom up if you're a machine builder, or you look at it from a manufacturer class from the top down saying, what are our needs, right? Our needs are, we need information models. So just extended further, I will say the asset administration shell is the critical piece, the next piece for us, as well as there's an architecture called RAMI 4.0, which is a reference architecture for modeling for Industry 4.0. That's the next layer up from us that seems to be the next layer up above the profile. So those out of that other slide that he showed, at least for us, you know, it's OPC UA, that's the foundation. Asset administration shell allows you to plug and play of equipment for flexible manufacturing. And then trying to tie it all together is this RAMI 4.0. So I don't know if you're going to get there eventually.
We'll get to RAMI, but thanks for bringing up asset administration shell.
Yeah.
And thanks for sharing your actual war wounds. Let me talk briefly about asset administration shell before we do our demo. I mentioned we had the the European contingent here yesterday, and they're very focused on a different use case. So we're largely talking about the machine up as being a data source that needs to be organized. Suellen's going to show you a demo of how adopting profiles can simplify connecting sensors, connecting equipment. That's a very valid set of use cases. This kind of middle layers, how do you tell the machine what to do and understand what it's doing is really important.
Job control.
Yeah, job control. And incidentally, it's ISA 95 for job control. So we're going to talk ISA 95, but that's in this world too. It's a slice of ISA 95 that has been encapsulated in a couple of profiles to make it digestible and accomplishable. Asset administration shell is largely, but not entirely, focused on a different use case. That use case is finished goods. If I ship you a battery that I have produced, you want data about that battery. You want a reliable way to get the information out about how it was manufactured, what's inside it, what things are dangerous, how to recycle it. Thank you. If I ship you a machine, I might want the diagrams that went into the assembly of that machine. I may want user manuals. I may want a semantic model describing the data that's in that machine. An asset administration shell is called that because it is a shell over an asset that contains the data about that asset. Inside the asset administration shell is a manifest telling you what's inside it. And one or more submodel templates is their word that describes the information model of the asset administration shell. A submodel template and a profile are the same thing by another name. And in fact, although submodel templates had a different XML format, we're moving towards using the UA node set XML format as the submodel format.
Hallelujah.
Agreed. Yeah, I think that might be lost on lots of folks. There were these competing XML formats, and we're finally resolving that. Inside an asset administration shell is a profile. Asset administration shells have other use cases. So while they're primarily thinking, because of regulation that's coming in Europe, how do I get information to a customer about a product? The asset administration shell can be used. We learned about smart buildings as a concept. The digital product passport is that probably first going to happen in EV batteries. What was the other use case we talked about yesterday?
Industrial batteries.
Industrial batteries. There was another one.
Everything over 2 kilowatt.
Yeah. And a machine. Like I said, a machine can have an asset administration shell. It's important to understand that these are not in competition. There was a Venn diagram of overlap where there was some tension that is being resolved, but an asset administration shell and its submodel template has embodied in it this same concept we've been talking about all morning, that we need to have a profile, a language for describing our data.
So just to follow up on that, because I see some confused looks. So typical submodel templates for the asset admin shell are digital nameplate and product carbon footprint, anything to do with a finished good, like Jonathan said. Obviously, the profiles for machines are, robotics and CNC, and they're specific to machinery, right? And OPC-UA is a universal modeling language. You can model anything you want with it, including machine profiles and profiles for the asset admin shell. But that's the middle of the Venn diagram. But really, the asset admin shell and sending data from your machines for data analysis are completely different use cases. Now, there were some research projects in Germany that used the asset admin shell also for sending machine data for analysis, but just forget that, right? That's not the use case for the asset admin shell.
You'll probably hear more about asset administration shell later, but it was raised as a good point, so I wanted to call that out.
I'm stepping back to capabilities, and when you say that the profiles have certain capabilities, and then I hear Anderson talking about the job model, the work model, it causes me to think probably in terms of functionality and then manufacturing execution. So when you talk about capabilities, is it they're actually transformational capabilities, or is it just organizing in the context of a capability of which you would then layer on some sort of COT software?
By capability, you mean like machine capability? Like what am I capable of doing?
Probably data science capability.
Data science capability. Yeah. I think not the latter. Okay, so there's a concept that I would call an interface profile. An interface in most programming languages most strongly typed programming languages is effectively a declaration of certain capabilities. So I could implement, by convention, most interfaces start with I. So I call it an I energy profile. That is a declaration from the machine that even though you don't know anything else about what this machine is doing, it implements this energy set of data. It does not implement the ability for the machine to do energy analysis, right? It's not declaring I am an energy analyzer, or that if you connect to me, I will give you energy analysis. But it is a declaration, an interface is a declaration that energy data, according to this standard, is present. Okay. Is that kind of what you're after? Yeah. Yeah. Now that we're kind of drifting towards composition over inheritance, I think we're going to see more of those capability type compositions or interfaces. In a strongly typed programming language, so a programming language where this concept of a profile is built into the language, lots and lots of IT software uses strongly typed programming environments. An interface declaration, if I say I implement this interface and I fail to, my code will not compile. My code won't run. We have no such strong typing in our space, right? There is no safe declaration of data in a manufacturing data source. There's at best like a heuristic match, like you appear to have this data, so I sure hope you mean what I mean. This is moving us in that direction where we may not have full strong typing, but we may be able to advertise certain capabilities in a reliable fashion. And that would be a huge move forward for understanding information in our space. All right, Suellen wants to show a demonstration of how profiles can make connecting to data sources faster. So hopefully this is a good context for that.
Yeah. Hello, everybody. And just real quick on the comment about the capability of analytics on top of this. One of the things was we were getting ready for this demo fest. I was working with an analytics firm and just taking the profile out to say, this is the data we plan to accomplish from or get from this. Then we can go and we can say, oh, I can do analytics between commanded versus actual. So you're talking to a piece of paper and the capabilities and trying to decide which way to go forward. And you have a plan A, you have a plan B. Maybe you have to add this sensor, but it goes faster because you start melding with it. So that's just my opinion on it. Hi, Suellen Lorkowski. I'm an application engineer at CESMII. 25 plus years in manufacturing. So I was a controls engineer, manufacturing engineer, as an OEM building equipment and as an OEM producing engines. Then I went as a solution consultant and application engineer to Rockwell Automation and to GE. And I learned that there was a whole world outside of automotive. So this is my, so what I'm going to do is show you a real life example of connecting sensors to the SMIP, Smart Information Innovation Platform, leveraging the profile. And what we're going for is data consistency here. So apps can grab data from it, people can grab insights from it. Before I get started, I want to raise a hands. I'm asking for participation because you guys have been sitting here for a while. How many people have tried to connect a sensor to equipment? Okay, keep your hand raised, well, or raise it again, if you had to use more than 2 or 3 software programs to connect it, display it, historize it, show an app. Okay, so what I'm hoping to show today is an alternate path to that. So in that case, you usually have sensor to PLC, to HMI, to historian or a database, and then you have an app because somebody that's off-site may want to see it, right? It takes time to do that. You're into different software packages. You have to learn those software packages, and if they're not intuitive, then you're wasting time with that. So here is an example of interoperability where we're going to leverage that profile. And the big thing here is that the architecture is, and I do have this if you guys want to talk. I have the sensor sitting here with my humidity sensor. I have the gateway over there, which is an MQTT sensor. And then it comes to the edge, which is my computer. And then the core of this, or the SMIP, is Smart Manufacturing Innovation Platform, is up in the cloud. So the big thing here is that the profile that we've been talking about for the last couple hours, or hour. And basically this could be as simple as a sensor, and you'll get to see how simple that is, or it could be as complicated as that robot one. It depends on what you're trying to describe, right? But the whole power of it is that it describes something. It has you have a piece of paper to talk to about what you're going to grab from that data, etc. So I have an example of one, and let's see if this flies or not. You guys can tell me if you like it or not. So how many people have a smartwatch? Okay, how easy was it to add your watch to a dashboard? You opened up your phone, you downloaded the Garmin app. In my case, it's a Garmin. You downloaded the Garmin app, you started it, and it said pick your device. And you picked your device, and it ran for a couple minutes, and then it showed up, and it showed you all the data that your watch is capable of collecting. And then you could go and change your dashboard, right? So Garmin makes their own profiles outside of their app. They import them in their app. Every time they get a new one, they put another profile or template or type into their app, and you select it. Easy, right? So if we translate that into smart manufacturing, that's what we want to do. We have our profile that says everything about this machine. And again, I'm going sensor up, bottom up. We have everything about that machine. We need to import it in to our smart manufacturing information platform. And that's when it becomes a type. Okay, a type is nothing more than a template. It's what you're going to copy off of to create that real life device. So again, in your Garmin, it has a type or a template, and it creates it and puts it on the dashboard. Okay, so you're going to see 3 things today. I'm going to show you about establishing the template or the type. So where are we going to find those? Where are we going to find those profiles? How do we import it? What does it look like when we import it? Then, instead of creating a model from that template, we are going to actually programmatically.
Oh, it's on the other.
Okay. Sorry, I didn't look. We're going to programmatically create the sensor in the smart manufacturing platform. And that is the faster time to value, right? We don't have to go and create it over and over again when we have a CNC, when we have a sensor, it just gets added. And lastly, we're going to relocate the sensor because sometimes you solve the problem on that machine and you want to move it, or you have to line balance. So, hey, we're putting a new product in. Now we moved it from station 1 to station 2. So I'm going to show you that. Sound good? Okay. So now I got to see if I can. Okay. put this all together. I guess I should be looking there. Okay, so now I'm on the web. I am in the CESMII Smart Manufacturing Marketplace. And this is where all the profiles that CESMII has approved to use exist. Okay, and I'm using NCD sensors, National Control Devices sensors. And you can see that there is a wireless sensor right here. So when I look at more info on it, this is where I can actually go in and either get that OPC UA node set that Jonathan was talking about, or I can view it in Profile Designer, because that's where I want to view it to see actually what data is in there. Pardon? Okay. No problem. So we went to the marketplace. We found the profile we wanted to use. We came into Smart Profile Designer, Smart Manufacturing Profile Designer, and this is where we can see that's our environmental sensor type. And it basically shows the variables or the data that we can get from this. So battery level, firmware version, our humidity, our temperature, our type. And in case this type is just what number sensor is this? Because, you know, different manufacturers have different ones. Okay. Now, remember, marketplace, get the profile, look at the profile, and the last step is, see if I can move this. Nope, hide. Sorry, I'm waiting for my team screen to go bye-bye. The last thing to do is to, oh, we're going to fix it. The last thing to do is view this in the Smart Manufacturing Innovation Platform, which this is ThinkIQ. You can see that we have types here, and again, types are just models. What are or templates? What are we going to take? What are we going to copy when we want a real-life device? So here is our temperature and humidity sensor, and here is all our variables that we saw in the Smart Manufacturing Profile Designer. Make sense? Okay, last one. So now comes the fun stuff. So now that we have a type, we want to actually create a real-life device on it. Okay, so when we create a real-life device, I'm going to programmatically do this. So what's going to happen is I'm going to flip a switch on my I/O sensor, and basically that starts pushing data to the MQTT gateway. Okay, the MQTT gateway is going to send it to a broker and publish it to a broker, and then we're subscribed to it. So it's going to automatically go in there and create this. Okay, so right now you can see that we're at the feeding station. There's nothing under here. And if we go under here for funds, for inspection, and for sorting machine, that's not in there either. So let's turn on our sensor, which again starts publishing to the gateway, to the MQTT broker. And then when we come in, we can refresh this. We can come to the feeder station. And I didn't wait long enough for 5 seconds. You guys all joined the network. That's what it is. It worked this morning when you guys weren't on the network. Okay, cool. So, no, it didn't show up. Okay. It didn't show up. I'm blaming network. So in the feeding station, we should actually have a MAC address of the sensor that we have on here with all the variables and sending the variables in from the actual temperature sensor. And it's not going, of course. Should have done it first thing this morning. Okay, it's not going to work. So if that would have worked, come see me later. We'll show it.
Well, so we're going to take a break. Yeah. Let's take an informal break now, and hopefully our latency issues are solved and you can come back and see that. And then we're going to switch to another topic. So you've all earned it. I think there's coffee. I better not promise. There was coffee yesterday. But there are definitely bathrooms. Plan to come back in about 5 minutes. Hopefully we'll see the end of the demo, and then we're going to switch to the next big topic.
And real quick, if you did not check in at the front desk when you came in today, please do so.
Oh yeah, make
you
sure
will
you're
have to
checked in.
check in tomorrow at the front desk also.
Thanks. Coffee's outside in the tent. Thanks, Eric.
CNC machine.
Profile is just a concept or is the software platform and what's the aim and deliverable of system?
I can't redo what I just did. The aim of the Smart Profile is to turn our data into identifiable data sets.
You're going to need an
discover at runtime in an operation.
Python can read it, yeah. Python second.
You can download them for free from the cloud library that we talked about earlier.
And in the case of these attributes are optional.
No,
Yes.
we aren't a vendor. We don't make platforms. We have a few key technologies, the first of which is profiles that we want platform vendors to implement to make sense of manufacturing data. We're going to talk about 2 more concepts after the break that other platform vendors can implement. But we aren't selling you a platform. We aren't telling you to buy a platform. We are telling the ecosystem that platforms should have these things.
Yeah, let's do it. Let's do it. Hey,
I really didn't get a chance to say hi
yesterday.
yesterday.
Yeah.
To say hi.
So we just spent the past hour and 20 minutes on it. I'm not going to be able to recap it right now.
Has John already briefed you on the recent issue we had with Rockwell? Okay, so here it goes. So I've been working with monoliths. Monolith 7% Rockwell.
People from academia that don't know what a schema, class, or type definition are might be in the wrong space. That's what it is. It's a schema. It's a class definition. It's a type definition.
Rockwell, Siemens, and Beckman. Gosh, if only there was a common configuration.
Profile is our label for a concept which is well understood in many domains. Schema, template, class, type. I can't think of another word. I can't recap the last hour and 20 minutes.
I've just launched does. Listen, oh yeah? Well, it sounds like that's what we've been looking for.
I don't think I'm going to be able to help you during.
There's actually reference
So why don't we talk
documentation
more
that we
later?
had to do as part of the spec work because we need to try it out, right? So that, we basically try this out, right? And make sure it works before.
No, show me that later.
So
Show me that later.
is it available? So yeah, it's open source, it's MIT licensed, so you can just use it. And they said, let's do an open source project. Right, let's try this out. And obviously, we can apply a solution, but in the meantime, we can try out this concept. And I said, sure, let's do that. Would you want to participate? Well, everybody, right? Well, everybody participate. Can you organize it? I said, sure, I'll organize it. So I organized it, right? And, Siemens, it's not a secret. Zero DNS, right? Backup pretty much stomped, right? Okay, don't know about this, but let's have a look at it. Rockwell, on the other hand, the monolith account manager, he pushed back like crazy. Tony, I think, yeah. So he said, "What is this? We have Ethernet IP. What are you talking about, right?" I said, "Well, it's an open source. It's kind of different, right?" And then Bart got involved and he asked me a bunch of questions, and I said, "Yeah, well, it's like this, right? It's an open source project. Monolith wants to run it." And he goes, "Well, I don't think Rockwell is interested." That's fine, but don't tell me, tell the customer, right?
How's it going?
Next thing I know, Andy, my boss says, "Hey, Rockwell is escalated. They're asking me to fire me." Yeah. Seriously, I'm not making this up. He said, "How can you keep Eric employed?" And my boss said, he's doing good work here, right? And they were like, you know, I thought you were in our, and my boss said, well, you are in our HMI booth. Of course you're our partner, right? This is a monolith project. And then he said, well, just apologize to Rockwell. And I said, apologize about what? Right? I'm just doing what the customer asked me to.
These are standard, like
it's a published standard. Yeah, it's part of the UPC standard. Yeah. Anyway, so that was stressful, but I still reached out to Bart and to Paul Brooks.
Yeah.
And I said, okay, what is the issue here? And so well, you made us look bad in front of the customer. I said, hold on a second, right? That's not my intention. I'm trying to help you, right? If the customer asks for this feature, let's work together to get it implemented. And Paul said, well, we won't be able to make those kind of changes in the timeline that well, that's built.
If you leave,
so let's build an adapter then. I'll build the adapter for you if you want. So you don't have to lose face
thinker for a while,
right?
Like did some of the.
But I mean, this has been super stressful for me. Super stressful.
Got a lot of hands-on experience there, and
no.
They're saying it's just.
I mean, right.
He knows stuff. So.
And then, I mean, they also escalated to the Microsoft partner manager, and the partner manager said, okay, what exactly is Monolith is asking you to do? They couldn't tell him. So he rang me and said, what is this? Yes. He said, what is this? And I said, well, I'll tell you what it is. It's a mess, right? And I mean, you could have just said, right, as an option, we need your help, Aaron.
All right, we're going to start trying to bring it back in. Grab your seats.
And even after all of that, I still reached out to Rockwell and said, okay, how can we fix this? Right?
We do still have a lot to cover,
but,
so
you know,
we didn't actually have a scheduled break. I'm just being nice to y'all.
Thank you. Yeah.
Well, it got quieter, but I think we're still missing about 40% of our people.
They're all implementing profiles.
They're all off building their first profiles. That's right. Yeah. They're on the cloud library right now.
They're registering. Register.
No, it's magic.
All right, so if after all that you're still uncertain what a profile is, talk to us after. We could schedule some more time. Obviously, people come from different backgrounds and have different terminology. We tried to cover a broad spectrum, but I understand there are different angles to look at this thing. So we could do that maybe more in a small group session.
Over a drink.
Yeah, over a drink would be nice. So the internet gods are smiling on us. So Suellen's going to finish her demo, and then we're going to switch to the next topic.
Okay, so we come back to the drill down into the feeding station. We see that there is a sensor with the MAC address, and we can see that the MAC address and the humidity, temperature, and battery level came in. It still is publishing, so these may change as we're talking. But that's easy what it is. We could have gone and copied it, right, and created it, but it's fun to do it programmatically. So the last use case we were going to look at was, hey, it was great. We got it on the feeding station. We had the sensors. We're going to move those to another station for either line balancing or moving it for troubleshooting there. And really easy, coming in and selecting a different station to be able to associate it with. And the beauty of this is that we are associating it with the station, but in the database, we're actually showing that it was associated with the feeding station and then the sorting station. So when we're doing our analysis on it, you can tell where the sensors were. And that's really popular line balancing Atlas Copco tools. Everybody has to move fastener stations and then they get all confused of which station it was on and et cetera, and your database gets confused very easily here. So again, saves time. So in summary, I'm going back to this slide, because you may have noticed that I didn't have any apps listed on here. And I didn't list those because I didn't want to confuse the situation. We are focusing on the profile data up, right? But once you have that foundation of the data in your system, then it's very easily for interoperability for those apps to come down and grab that information. So it could be SAS Analytics predicting that your vibration is too high and it's going to your machine's going to shut down in 2 days. It could be Maximo. Hey, the temperature was too high or the sensor's not working. Go out, check it, open a work order and check it. Or it could be Symphony AI where, hey, we're going to kick off a workflow because the temperature went too high or the humidity is too high and our product goes bad. Okay, so thank you. For more interoperability demos, Jonathan already mentioned the Demo Fest tomorrow at 3:30. It's actually called Smart Manufacturing in Action if you're looking on your agenda. And if you have any questions, please reach out to me during the break. Thank you.
I'm on. Okay, so what Suellen showed was a profile starting its life in the marketplace, which is a front end for the cloud library, pulling that profile into a smart manufacturing platform that then lived inside of ThinkIQ as a type definition. A type definition is abstract. It's like a class or template. It didn't belong to anything until a sensor came online. The platform was able to match the sensor to the type and create an instance object of that type that it affixed to a parent. She then reparented that. She changed the relationship of that sensor so that it belonged to a different thing. And she did all of that without any code or much in the way of user interface configuration. I feel like I'm louder after the break. There's a concept that she introduced there that we just kind of brushed over, which is the relationship between the sensor and a part of the hierarchy. And the hierarchy question was asked earlier. So that's where we're going next. Problem number one, we want to solve through standards. Those standards may be published official standards. They may be internal standards, but wherever possible, those internal standards are informed by published standards and are enforced internally by the software you use and by a cultural discipline to begin to standardize your data. The next problem is identity and these relationships. We partially solve a node's identity by understanding its type, especially if the type definition includes identity information. But we don't have relationships until we bring in another layer of software and maybe a clicker. Thanks.
Oh, that's it.
Yeah. Maybe it just needed to be focused. Okay, thanks. I'm just going to try it real quick. Yeah, it was just out of focus. I had to import a clicker all the way from Germany. Yeah. Human clicker, thanks. We typically express relationships in manufacturing hierarchically. Whether you're in automotive or not, a hierarchy like this probably looks familiar. Most of our higher level information software has tools to help us define these hierarchies. If you don't have such a tool, but you've built a unified namespace, you probably have an implicit hierarchy in either your topic structure or your payload structure. These hierarchies are kind of how we think about organizing manufacturing information. These hierarchical relationships have some advantages. We have this sort of parent-child structure. We might, in the abstract, call each of these things a node, but those nodes have parents, and parents may have children. Typically, a node has one parent, but may have multiple children. This is how hierarchies cascade. Hierarchies lend themselves to certain kinds of information analysis. And we've been taking advantage of this since the 90s. Given a hierarchy where A, B, and C are siblings of a parent, I can infer that machine C might be starved because machine B is faulted, right? Things aren't flowing through my family the way that I expect them to. I can also do roll-ups. So given that B was stopped for 3 minutes and C was starved for 12 minutes, I can probably roll up and do some summary analysis on A that it was probably down for 15 minutes, whether I could count A's downtime or not, right? This is how we use hierarchies to extract information value from the data we collect on the elements of the hierarchy. Manufacturing is actually not hierarchical. Some parts of our operation might be hierarchical, but if I am producing a good, that good doesn't really have a parent-child relationship with a piece of equipment. It doesn't have a parent-child relationship with a human operator. It doesn't have a parent-child relationship with the manufacturer of a sub-assembly in case of a car. It actually has these mutating relationships with multiple parts of my operation at a given point in time. Hierarchies, despite having some information value that we've extracted, are also very limited when we go to express what's actually happening in a manufacturing operation. We need a newer approach to understanding manufacturing information, and that newer approach is called graphs. In a graph, I also have nodes. Nodes also have relationships, but those relationships are not necessarily hierarchical. I can actually grab a node in a graph and pull it up to the top, and something like a hierarchy might cascade out from it. But then I can grab any other node and find the relationships that scatter out from that. Manufacturing relationships go off in these orthogonal directions, and those relationships change over time. This is a somewhat contrived example, but it's worth a walkthrough just to kind of fully explore this idea. Let's say that nodes A, F, and D are all pieces of equipment in my manufacturing operation. They could even be CNCs, and they're all on the same electrical circuit. This is one relationship that I often don't capture in my manufacturing software. Another set of software that does network analysis might show us that nodes B, E, F, and G are all connected to the same network switch. So they have this Ethernet relationship with each other. Nodes A, C, and E might have been expressed hierarchically in the same area. They might have the same equipment parent or the same organization, right? So we have these three sets of relationships that maybe different software packages might understand, but aren't gathered in any one software package typically. Contrived example, but assuming our network is in ring topology, if node A has an electrical problem and overloads its circuit, everything on that circuit goes down. But because one of the nodes is also on a network that's communicating in a ring and it's just gone down, all of the nodes in that network relationship are impacted as well. If we don't have these relationships captured, we can't find that causality without actually going and investigating what went wrong or creating some human-made theory. And those human-made theories and those human investigations have value, but they'll never get us to an AI telling us what's going wrong in our operation. If this collection of nodes is one area in my plant, and that area in my plant feeds other areas in my plant, then I can follow that causality to impact in other areas of my plant. This is another set of relationships. This graph that we articulated for this one area now expands to have nodes and edges that go out to another area. And if I keep zooming out on this graph, that plant is part of a supply chain that supplies to someone else who is now part of a graph. So our graph theory can start at the smallest level, capturing all of these relationships that I may or may not have articulated, I may or may not understand, and can zoom out across a global supply chain. Conversely, if I'm looking at a global supply chain and trying to predict problems, I need to be able to zoom back in and understand the relationships that make up the parts of my supply chain. A graph is not just a better way to articulate a hierarchy. A graph is this layers of an onion, each layer composing a new set of nodes and relationships that have impact on each other, and that are impacted by what's happening deeper inside of the graph. Does this make sense? We generally don't use graphs in our space. The maybe popular social media conversation is beginning to explore this idea of knowledge graphs, which I applaud. I think anything that sort of introduces us to this graph thinking is a good step in the right direction. We have this legacy because our systems have allowed us to express hierarchies, and so we've organized hierarchically. But we need to bust out of that hierarchical limitation and begin understanding the relationships in how our machines work, how our plants work, how our supply chains work. Even though this is relatively new to us, and we're talking about it at the level of knowledge, which I think is great, graphs aren't actually new in information technology. Cambridge Analytica famously used the Facebook graph to exploit Facebook members in a previous election year, right? They weren't just following explicit relationships. They weren't just looking at who is a friend of whom. They were looking at these other less explicit relationships in the graph, like what group of people liked similar topics, what group of people shared similar things. They were exploiting this Facebook graph for information insight that is not available to us in manufacturing because we don't have systems that can preserve and present this graph to analysis tools. We have to move towards graphs. Another example of graph thinking is a neural net. Unsurprisingly, nodes in a neural net, which is our best mimic of the human brain, has these nodes and edges that are interacting graph style. Maybe more surprisingly, ISA 95, if you actually fully realized it, looks like this. This is a picture of ISA 95 as the current version is intended to be implemented. It is not a hierarchy. We think of ISA 95 as a hierarchy because one of its core parts tells us how to shape a hierarchy. But if we fully realize the job relationships, the asset relationships, the people relationships, the supplier relationships across ISA 95, it is a graph. We need tools that allow us to capture these graph relationships, understand, visualize these graph relationships, but also expose those relationships to software so that we can take advantage of machine learning and magical AI that's going to do things for us that we're seeing in other spaces that is not available to us here because we have limited our thinking to hierarchies and subsequently limit our thinking to untyped objects. These two concepts build on each other. Nodes are objects of a type. Nodes have relationships with each other. Those relationships must be in graph style, not limited to hierarchical style. And finally, software needs to be able to look at those relationships as they change over time. A machine may be organized into an area, but it has an operator who's going to work on that machine for a while, and then he's going to go home at the end of his shift. And now there is a new node, a new operator with a relationship with that machine. If I want to do analysis on operator behavior, I need to know about those changes in those relationships. The graph needs to be able to mutate over time. I can pause for conversation, but I see everybody nodding. Conceptually, I think this makes sense. Our limitations have been our software to date. So we have this concept I introduced earlier, smart manufacturing profiles. Smart manufacturing profiles are technology agnostic. Anybody can implement them. Graphs are technology vendor agnostic. Anybody can implement them. It's challenging because the tools we've had have never had this before, but other ecosystems have graphs. Yep. So we can too. Yeah. Oh, you still have a mic. Switch on the bottom.
Can you hear me? Thanks again, Jonathan. No, firstly, forgive me. I came in a bit late. But in hearing you describing the graph, I'm thinking that some of the concepts still overlies with hierarchy. Explain why you say it's totally dissimilar.
I can use a graph to articulate a hierarchy, 100%. The hierarchy is one set of edges that are relating my nodes. And I'm not actually saying throw out the hierarchy. What I'm saying is add other edges, right? Every node has other relationships that aren't necessarily hierarchical. When we talk about it, we literally talk about hierarchical and non-hierarchical relationships. Hierarchical is what we have. Non-hierarchical is what we want to add to it. Other thoughts? Yep. Mike? Already on.
One concept that keeps going around in my brain that we're kind of hung up on now is also the idea of the graph as an input, not just an output. So thinking about the properties of the nodes, relationships between the nodes. So like this computer sends data to that machine, or this machine feeds that machine, being pushed into the manufacturing environment is like an infrastructure as code approach. And the properties on the nodes being used to configure the parameters of the machinery or the system. And so it can change in real time without having a hard-coded backend. So using the graph as both an input and
output. So could you give an example of how you would use that?
Yeah, so a good example is if I want to add another MES station or I want to have a machine feed a different machine, I want to insert something into the system, as opposed to gathering a cross-functional team to reconfigure multiple systems to do that on an entire project timeline. You could just have an interface that allows you to update this graph. The system pulls that graph into itself. It uses that as its marching orders for its runtime state. The system reconfigures itself against that graph. And it's done that automatically without having to spin up entire teams to think about how to reconfigure the system.
Yeah. One of the graph relationships that's in ISA 95 that was a relatively new term to me about a year ago, something called the equipment train. So if you already knew what an equipment train was, you can school me later. But an equipment train is different than the equipment hierarchy. The equipment hierarchy is how I laid out or organized my equipment, how I might want to roll up analytics. But the equipment train is the particular flow through equipment of a job. So this job is going to have a train that flows this way through the equipment, and this other job has a train that flows this way through the equipment. I am not physically relocating my equipment. I don't want to change my hierarchy. The hierarchy is still useful, but for a period of time defined by a job, I want to change the flow of material through that equipment. That's a set of mutating graph relationships that if we were to do a ISA 95, we need to be able to capture in a graph. All right, we have an example for this as well. And one of the CESMII members who's maybe furthest ahead on this is ThinkIQ. So I'm going to invite Doug Lawson up to show you how they visualize and use graphs in their software. Oh, thank you.
There we go. Can everybody hear me? Good. Jonathan, thank you so much. A quick word, a little bit about myself, CEO of ThinkIQ. I've had the privilege over the last 30 years to do multiple startup companies. That's fun. Created technology that's in use in about 1.5 million different processes, or factories and plants around the world. That's also fun when visiting. And also had the opportunity, after selling 3 companies in a row, to work in each of the biggest industrial automation companies in the US. So it gives me a really, really interesting perspective on the industry. I was very fortunate 8 years ago to be approached by the folk at UCLA and the people from the Smart Manufacturing Leadership Coalition who said, well, you look like you're about to retire, but we're thinking about putting together an open software platform for manufacturing that's going to completely change the world. And at first I looked at Jim Davis and John, actually at the time, Jim Wetzel, and it was like, you guys are crazy. Never going to happen, talk to somebody else. And somehow I got dragged into the process, and it's been an extraordinary ride to watch players like Microsoft, our friends from Industry 4.0, CESMII all come together, and we have something truly extraordinary happening at the moment. ThinkIQ is one of the vendors at the table creating and making this a reality. We were just incredibly fortunate from a timing perspective that we were one of the first in this process, and we have the first implementation of the specifications for a smart manufacturing interoperability platform. We actually are welcoming and excited about the fact that other vendors are stepping up and doing the same thing, because it's adoption by the vendor ecosystem that will truly drive adoption by the community. So we're thrilled that we're no longer the lone vendor in the middle of that. However, we are the ones who can, at this point in time, show all the key concepts that Jonathan has shared today. And I'm going to spend a few minutes just going through that. So let's start with the first part of what Jonathan spoke about, which is profiles. Profiles are created by the expert organizations or yourselves, typically using the CESMII profile editor. And that's the tool that you're looking at right now. There are approximately 200 profiles available in the marketplace. My account that I'm logged into at this point in time only has a handful. And it has that because I chose to import into my account, I chose to open the CNC profile. And why did I choose that one? Because it's a community-created profile, largely created on the back of a bunch of CESMII projects. And it is the same profile that we're using to connect to the CNC machines that you will see on the walkthrough later today. So that's the reason why I chose that one. I've taken that profile and I've edited it. So if we go and look at the CNC base profile, we'll typically see the types of information that sit inside it. So if we go on to the type definitions, we'll see the things that you would expect to see. A definition of the axis, the spindle, the commands that are being executed by the system, the coolant, the main motor driving the CNC machine. This is all stuff which is very familiar to people. How do you get that into your instance of a platform? The conversation that was happening earlier today was, how do you choose them, and then how do you use them? So the process is relatively straightforward. So what I'm doing is I'm shifting now to an instance of the SMIP. So every customer typically ends up with their own instance. And we're looking at what's called the Model Explorer, which is the built-in tool that allows you to navigate the types that you have in the system, the instances that you've created, the hierarchy that Jonathan spoke about, and the graph from a single place. So this is where you would create your content. This is already a relatively rich area that we're looking at here. So Jonathan showed the automotive structure. So I just chose to drill down into a demo system. So I'm following the hierarchy in this fictitious automotive company. I'm from the Orange County plant. I'm in the stamping department. I'm on the press line. Within that, I've gone to a specific press that's pressing out chassis, and I've clicked on a motor. Why? Because a motor is a simple thing that we will all understand. And the data that we're seeing over here is real-time data flowing into the system. As we click around in this particular platform, you will see motors that are providing data over MQTT, others that are providing it over an OPC UA protocol, others that are providing it because the data is flowing first to a data historian, and that gets the key point across that Jonathan was emphasizing. The structure of the data for motor exists independently of how that information flows into the system. I also have sitting underneath it a nameplate. This is completely different. It exists in the platform as a type and as an object, but this came from asset administration shell. So it harmonizes, you're seeing objects in the system together that have come from two very different areas. I do not have any CNC machines in this system or a CNC type. So let's go and say to the system, show me the libraries. So profiles are delivered in collections of profiles that we typically refer to as libraries. And let's go and say, I want to import a profile from the cloud library, which is the new standard that was created. Wow, this Wi-Fi is slow. So can everybody please get off the Wi-Fi? Now? All right, don't worry too much about it. So this instance of the platform has reached out into the CESMII cloud library, and it's showing us all of the profiles that exist there right now. So we can look and see personal ones that have been created. I have no idea what I'm going to see if I click on Jonathan Wise and Dave Wickman, but these are the publishers of the system. We can see ones that have been created by the OPC Foundation. That one's for beer. Dave, thank you. That's brewery. So actually, I did have an idea what was sitting over there. And I happen to know, and I could obviously search in here and go find it. So we can search on all of the attributes. This is the area that we're hoping to see get much better, because you can see it's already becoming overwhelming. So we need to understand these have been deprecated. These ones are used. This is really compatible. You know, we've got to be able to add a whole lot more metadata to these profiles in due course. But here's our CNC base profile. There's more information that we can see on the base profile. Importantly, profiles can be dependent upon others. So it's looked and it's said, you don't have the OPC Foundation dependencies installed on this system. Do you want to bring them in too? So we're dependent on machinery, UA's base profile, and OPC UA DI, which is for devices. Yes, thank you. And there's a lot of them in this point in time. So let's go ahead and import this profile. So it's giving me a little bit more detail. It's telling me that it is about CNC machines. It's telling me that it contains 13 types, and we'll go away and just start the import process. So I see a bunch of really ugly looking stuff here, which is the under the hood profile names, but it's as simple as that in terms of bringing a profile into the platform. So let's quickly move back into my model explorer. And so I will go back into applications model explorer, and let's go and look at what happened under the hood. So we have our types. There's lots of them on this particular system. We've had many libraries, and this is common in this environment. So it's not unusual to mix and match and say, I want libraries that are machine specific, libraries that are material specific, libraries that are supply chain specific, libraries that bring in graphs. There's a rich group of them. This is a demo system, so it bristles with them. Let me go select them all, unselect, and go down to the bottom of the picture. And here are the libraries that have just been brought into the system. And I'm just going to go ahead and say filter on those two libraries so that it narrows my focus down to the things that I care about on these profiles. You'll see that I now have in my type system, I have the generic OPC UA object that's come into the system. Everything in that derives from the base automation type. And we can drop down further into the system and we can see the same information. So here's our axis type, which has an attribute on it, which is its offset and its status. We can see the cooling system. We can go to the motor. And on the motor, we see things like the current efficiency, load rate, RPM, vibration, the things that collectively the folk in the CESMII projects agreed that they all would like to see in a profile for CNC machines. Jonathan touched on another critical piece of concept here, is that what you're getting from profiles are objects. Objects in a perfect world have behavior. That's not always true in all systems, but it is true in the CESMII, Smart Manufacturing Information Platform. So objects are programmatic. You can run them. They can have smarts behind them. They can be full-featured digital twins running inside the platform. So let's take advantage of the programmability of objects in this situation. And I'm going to go to my instances. I'm going to drop, and I'm going to get a little bit geeky here for the moment. I'm going to go to the place where I have a script over here that says create and wire a CNC machine. And this script is really important. We spoke about the work, our world exists of brownfield and greenfield projects. And in the future, we would anticipate that we would just be able to connect to CNC machines and have the data flow. Our reality in a facility like this is that that doesn't occur. It's brownfields. But the beauty is these objects are completely programmable, and there's a rule set here that allows us to say, we know some of these are Haas machines, some of them are others. Let's just run some code. So I'm just going to open it up inside the platform where we can add code. I'm going to take roughly 50 lines of code, and this would be written once for my machine type, and I'm going to go ahead and say, run this code. The code itself is uninteresting from the perspective that it's simply going and mapping tags on a specific CNC machine to structures that are known to be coming in from UA. But it gets rid of the physical mapping processes that you would typically follow. But it also goes ahead, and I'm now kicking myself for having done this demo in the wrong sequence, because I wanted to show the graph before I actually ran that script, but let's go ahead anyway. So we've spoken a great deal about the graphs. So let's go and look at the graph that describes this automotive structure that we were just looking at. So this is a fictitious automotive company. So it is the front overview. And what we're looking at here is the graph, and that one's way too detailed. Let me drill down into a subset of this environment. So I'll focus on the stamping environment. And we're looking at a very, very specific graph here. So when this process layout was configured, the person who configured it said, I want to see all equipment here in the hierarchy. So it's very importantly, hierarchies and graphs are not mutually exclusive. And I want to see all equipment related by a particular relationship. In this particular case, the relationship is can feed. So materials can feed from this piece of equipment to this piece of equipment. There are many types of relationships that come and can be added by profiles. So if we go and look at this, but I stole my own thunder. What I intended to do here was bring up this graph and not have a CNC machine in the picture. When I ran that script, what happened behind the scenes is it added this bearing turntable that is feeding bearings into the chassis press from a CNC machine. So this is my CNC machine. If we take that, I can go and I can click on it to the Model Explorer. And we'll now go into the instance of the CNC machine that I just added. Let's drill down. And if I remember correctly, a good place to go would be the spindle list. And under the spindle list, I will see various spindles. So this is the machine. And I want to go to the attributes. I believe remember what you're doing before you go into a presentation. There's live data on here somewhere. I'm just going to organize my thoughts as to where the live data is coming into the system. But what's being created here is not only an instance of a CNC machine, it's been automatically mapped to the data sources through programmability, and it's been added to the graph in terms of the material relationships. So you're seeing all of the key concepts come together here around how we create those graphs. If I have time in a second, I'll come back and actually hunt down the historical data that you would see here that is now flowing, or the live data that's flowing and being stored into history in an automated fashion on the CNC machine. But I want to zoom out a little bit further at this point in time and come back to some of the details of the graphs. So the graph that I chose originally is one of the most common. I said, show me the stamping department. And we saw the relationship of how machines relate to each other through the flow of materials, a can-feed relationship. But there are many other relationships. They include things like, where does the energy come from? Very importantly, we're working, part of the initiatives yesterday is to really standardize on what's the real carbon footprint of the materials that get produced. Where does energy flow? What does energy look like on the bill of materials? To be able to do that, it is as important to be able to map where your water, air, gas, electricity, and steam flow through your plant as it is to be able to map the physical flow of materials through your machinery and the mappings between people and the machines themselves, which we'll demonstrate in a few minutes. So this is a different graph looking at exactly the same equipment, where we're now looking at the electrical distribution, and we can see how electrical power flows to the different machines that we've seen. Jonathan, I think I'm at time, am I not? Excellent. Thank you very much.
So as a quick recap, we brought in the profile for a machine as a library into ThinkIQ. We found an instance of that profile, an actual machine that embodies the profile. The machine was added to a view that looked fairly hierarchical, fairly traditional, but it also exists in this other set of relationships that are wages, water, air, gas, electricity, and steam. So another set of relationships for the same piece of equipment that was profile-based. Yeah, go ahead. Can somebody run him a mic? I need to do screen. Switch at the bottom.
Thank you. John Harrington from HiBite. That was really cool. I'm still trying to wrap my head around exactly what ThinkIQ is. Do you consider it like a historian with a graph on top that can consume?
Somebody pass Doug a mic. Yes.
Sorry, we may go back and forth a little here. Got to turn it on.
Push at the bottom.
This is like being on a Teams meeting where someone starts talking and they're on mute.
They're on mute.
No, you're on mute.
It's the truly well-hidden mute button.
We're just not used to not being on Teams.
I do want to be respectful of this as a CESMII event, and our intent is not to plug software, but thank you for asking the question.
I'm a software vendor too, so that's cool.
Under those circumstances. So ThinkIQ is an implementation of all of the things that CESMII was talking about. In order to do that, we needed to build connectivity infrastructure. So it is both a cloud and an edge-based solution. The edge-based piece has everything from, and Rob will show it in a few minutes later, a vision ingestion system that allows us to turn cameras into first-class sensors. We have partners here who Plain Sight Technologies, Redbrick Systems, who are building applications on top of that capability. That'll be demoed tomorrow. The data ingestion sends the data to the cloud using for the internet level OPC UA protocol as the transport. It doesn't matter what the transport is at the edge. It brings it into an object relational store that gives you that structure that you saw of all the objects that have live data. So it maps into that. And it's also a hyperscale historian. Okay. So under the hood, any time series data, every time anything changes, will always be historized. That's audits to the system, changes to people. And then finally, and perhaps most importantly, if you've ever watched John Dykes talks, where he talks about collapsing the complexity of the software stack that's typically on the software floors. Like you'll see 50 applications in the automotive example that we gave over here. The platform also has extensibility. So you can build applications that are very loosely coupled to the application that just get data over the GraphQL API that essentially looks at everything we just described, always through the graph model, which is by far the deepest view into the system. That can get you to the real-time data and the historical data. And we also have applications embedded deeply inside the system. So at this point, there's companies like Fullbore, BrickRed, Plainsight. Who else has embedded applications available in the marketplace at this point? I know there's others coming down the pipeline.
Okay, no, that's cool. So I guess my question, to bring it back to the graph piece, does the graph get programmed by someone, or does just having the data and the data having edges, you can walk the virtual graph that was never programmed, you can just kind of start walking your data?
That is a great question. Most users end up initially creating their first cut of the graph manually. So I should have showed that in the Model Explorer, how you actually do that. There's a graphical tool that allows you to do that. Most users start with the built-in relationships like CanFeed, which really ties materials to equipment in a very elegant way. Most times the CanFeed relationship is created by hand. We do not recommend that. It is always better with something as information dense as a graph to try to program it, to create it programmatically. So for example, in the CNC case, we would typically look and say, when we see the tool number on the CNC change, that changes the graph about what material I'm currently running. So you can have code that picks up, sees the tool number change. It says, I know that's associated with this product that I'm producing, and then changes the graph to say, this machine is currently producing this product. So 9 times out of 10, the graph ends up programmatic and being programmed in response to more business data than machine data. Coming back to the comment that I think Anderson made very well, you want to be able to push behavior from the top down by the definitions of the products and jobs and things that you're running. You want to be able to push down. And I'm realizing that I should just have given this question to John, who would have answered it far better than me, in that he's a natural practitioner. So John, I don't know if you want to chime in on that, but certainly creating them programmatically, I think, is important.
Yeah, so for our environment in the real world, we have 9 ERPs and I don't know how many different MES systems, right? So we have never been able to model our real manufacturing process. So what the graph database has been able to do, which is exciting for us, is to actually model what's really going on out there. As much as the ERP and MES vendors claim you can model a complex process like this, the graph database for us has been a critical eye-opening of being able to actually model what physically is happening and really becoming, to steal a European term, our cyber-physical production system. That's really what from our perspective we're experiencing with a platform like a graph database.
Can I spend 30 seconds on that word model?
Yeah. So
a model, in our view of the world, starts as the model of an object. So if your ignition or optics, it's a UDT. That's your first model, is those individual objects. In Highlight, I would literally call it a model. So that's the first model. And to be clear, we're saying information modeling. Our data science friends here, for model, they mean the AI model, which we also want to talk about that. But from our perspective, if we don't understand the data by modeling the individual objects, we don't really have hope of doing good repeatable data science. So the model starts with the individual objects. Objects are of a type. The only thing I would add to what Doug said is that ThinkIQ provides a type-safe environment. So when I find instance objects, I can look back and find their type. And if their type came from a profile, I can know that that object is of this profile type. The model starts with individual objects. But to actually model a manufacturing environment, I need to understand the relationships between the objects. So I expand the word model now to include the graph model, which is how these objects are related and how those relationships change over time.
Yeah, ultimately for us, this model is becoming the foundation for a unified namespace architecture, where any piece of data that comes in can be related back to something that can be universally viewed and understood by the entire organization.
That is this problem. This attribution problem is when a piece of data comes in, what does it belong to and what is the context in which it existed?
Yeah, it's exciting for us to actually see in one graphical visual form with multiple relationships what actually happens in a very complex manufacturing environment, right? That, again, never been able to do that in ERP, never been able to do that in an MES system, never, because again, with the limitations of a classical relational database that all those solutions are built on, you really needed a graph database to understand that complex world of material flow, equipment relationships, people, that whole thing, right? That's exciting for us to actually be able to see that.
There's a question in the back.
Thank you. My name is Sean Madhavaram, and I'm at Georgia, MEP, Georgia Tech.
Hey.
I think I understand, the instance, the model, the object and everything, but still the question I'm still trying to answer in my mind is every time there's a dynamic relationship that is being, defined or changed, right? Who is doing this? Who's drawing that physical link, right? I mean, somebody has to do that, right?
Drawing the relationship line.
Exactly. So is that being done automatically, or how's it happening?
Yeah. So first of all, our first set of relationships probably are drawn by a human. I wouldn't call it programming, I would call it modeling, right? Like I'm going to draw my hierarchy. We're probably all starting with hierarchies, but then I'm going to start drawing these other relationships. That modeling might in its first cut be done by a human. But what Doug was advocating for is that probably in the data are indicators of these relationship changes. So it would be good if the focus of software development were not rewriting hierarchy tools or rewriting connectivity, but instead focusing on how do we write the code to discover these relationship changes and reflect that into whatever the system of record is for these graph relationships. That has to be done programmatically, or you have to have like really, really good modeling rules, which I don't think anybody has, where a bit change indicates a set of relationship changes. That might be like a material train. Like I'm going to change these relationships based on a bit that indicates I've started a new material chain. But even that's probably going to involve some programming. What we're not actually saying here is that we're moving towards a no-code world. I don't believe that thing exists. What we're saying is that the focus of our software development should be in this new area, not in repeating the old areas. So vendors are rising to the occasion. Doug wants to say some more. That is kind of part of CESMII's thrust, is how do we get people thinking about that problem set? I don't have a mic, but.
The mute button. I wanted to just give a couple of practical examples because that's a really, really important question. At the largest deployments that we have at this point in time, the source of the master data for the graph comes from a variety of different systems. So I'm going to give practical examples. Which operators are authorized to operate which machinery comes out of an internal database, which is about people and training and certification, and that's dynamic behavior that changes on a continual basis. That data is loaded constantly out of that bespoke system typically. There's a very important piece of data which goes into the graph, which sits around maintenance and asset definitions. So things like those nameplates that you saw, and then when was maintenance done and what maintenance procedures need to go through, typically come from the maintenance management systems, and the graph is dynamically loaded from those. There's a set of materials, things that relate to the rules of production that typically come from the MES or ERP layer or both, which are bills of materials, and physical plant alignment information, which typically comes out of the MES systems. All of those things are best loaded programmatically. So,
and when we talk about software interoperability, the goal is not to have one piece of software that can do everything, but make sure that we have a mechanism by which these different pieces of software can communicate against the same set of data. The object becomes the thing they're interacting with. We're not stitching together APIs, we're stitching together behaviors and relationships from these disparate systems against a common object.
And please, people, come to the demo fest tomorrow. That's the because you'll see 7-minute vignettes of a lot of this,
a lot of different ones,
many vendors.
Eric, you have 30 seconds because we have one more topic we got to hit.
Perfect. 30 seconds is enough. So one of the things we noticed is that people actually struggle with that initial graph hierarchy, just getting that up and running. So we've been working with the Digital Twin Consortium to create a tool that derives that graph hierarchy from the data sent to the cloud automatically. It's called OPC Twin. It's open source. You can find it on the DTC GitHub website. And it actually creates the graph on the fly as data starts flowing. Now, there is a caveat, which is, of course, you need to model your edge infrastructure and your connectivity software in a way that exposes that data. So if the data doesn't flow, it doesn't work. But it actually does a pretty good job of approximating the initial hierarchy, and it's definitely better than starting from scratch.
Okay, one more topic. We're running out of time. This one, fortunately, I don't think will be terribly controversial, but we do have some other business to cover at the end. Problem number 3 then is history and availability. And I know that you're saying we've had historians forever. I've worked with some of them. I am not talking about the history of samples. I'm talking about the history of relationships. I need to know for a given query what relationships were present at that point in time. I need my systems that I query for history to know how to service a query against an object, not against a value. I don't want your time series history values. I want to know the state of an object and its properties and its relationships at a given point in time. That's what I want from history. So if we go back to our little data science problem here, I can turn those data sources into instance objects of a type using the profile. That's a good start. But if the tools that I'm using don't know how to service a query about an object, don't know how to tell me which objects of a type exist, don't know how to tell me what the relationships between those objects are or were, then that data is trapped in those systems, and we have no hope of interoperability. Traditionally, in our space, we see APIs appear around level 3. This is where software gets complex enough that people start asking for APIs. There are some good ones out there, some of them represented in this room. There are good APIs that understand the data that is in that particular system. Those APIs generally don't understand the concept of a common profile, and to the earlier point, don't generally understand how to service requests about historical relationships about objects of a type. Our APIs need to evolve. This is the part of the demo where I don't, or the part of the presentation where I don't get to show you or forecast what the end state looks like, because we're all very much still working on this together. Some of the vendors here in this room are working on this with us. APIs need to evolve to encompass these prior 2 principles that we've been talking about. So these things build on each other to enable an evolution in our space. First, profiles or type definitions, objects of those types, then relationships between objects, and finally, but crucially, APIs that understand all of those things and can make them available to other tools so that we can interoperate. A brief excursus on UNS, because I promised that. I'll try to fly through this because we do have one more demo about interoperability we want to show. Let's just hang out on this one. In general, UNS is a hub and spoke architecture. That's one of its strengths, right? I have publishers, I have subscribers, and I have things that are both. If I have the discipline to create my UNS well, to enforce my UNS inside of my organization, to hopefully inform my UNS using published standards, I have some of these things fixed. But I also have a whole bunch of gaps. We are going to show a UNS demo tomorrow. I just want to highlight a few of the gaps, and I don't think they should be news to anyone. But the retain flag does not make your broker a historian. That makes sense? I still need history. A broker is a great way to flow data through. Some things can be retained, but that's not a historian. If I'm going to go all in on MQTT, I need to augment it with history. Secondly, your broker is not an API. That also shouldn't be anything we argue about. I can subscribe to data, and I can get that data, but I can't query for data. In SparkPlug-B, I can send a message that gives me the end birth, which is beginning to be API-like. In fact, it begins to give me a type definition. But this is not an API. This is not a query layer. It's a message passing infrastructure. It's a cool one, but it is not an API. And finally, a broker by itself does not include a namespace authority. So this notion that I can unify my namespace just by policing the contents of the payloads and topics on a broker is not sufficient. I need an external document that governs the types that make up the namespace. We would call that a profile, and it is not incompatible with the UNS approach. It is simply a complement to UNS approach, just like an API and a historian would be. There are a few, so these are realities of the technology that you can work around, and vendors help augment UNS, an MQTT-based UNS approach by providing their capabilities to, for these extra things. The other reality, though, is that in most implementations, we're not following good practices that would let our UNSs ever contribute to this world that CESMII is pushing for. Our message topic, especially if I'm not using SparkPlug-B, tends to be notationally hierarchical, data source defined, or some internal convention. The internal convention is most like tag naming in a PLC. I'm inevitably going to end up with a map. Data source defined forces me to ingest and republish according to my internal convention. And if I try to use the topic name to suggest context, I'm going to be limited by that field to hierarchical notation. Somewhere a map must exist to map that payload, which presumably belongs to an object, into a graph. That can't be done with just the topic name. Maybe it can be done with the payload structure, but in MQTT in particular, the payload structure is anything I want it to be. SparkPlug-B helps. It gives me rules for creating my payload and structure and then enforces those rules. But it's still up to me to know where to map this data to in a graph view of the world. Some system of record must persist and service the graph. So MQTT is cool. I'm pro MQTT. You'll see it in our demos. Much of my house is connected that way. All that's important to understand is by itself, it's not going to get us to this vision of the future that CESMII is trying to point to. We need to collaborate and interoperate. And if MQTT is a part of the architecture, we can do things to improve or augment its state, but we cannot consider our UNS a completion of this journey. So what is an information model? It's all of these things. It is the data model that helps us define our objects. It's the semantic model. It is the rules for the naming convention of the members of our objects. It's the ontological model. What is the meaning of each of those data points? It's the structural model. If I'm using MQTT, how do I structure the payload? If I'm using any other environment, it's more literal object-oriented programming. How do I define the class which informs my instance objects? It is the object model, the persistence of those objects of a type. It's the relational model, the graph model, that allows me to understand all of the many relationships of my objects as they change over time. And finally, it is the API that services access to all of that in a type-safe, graph-safe way. If we have all of those things, then we can begin interoperating a wide variety of software and focus our software development on extracting manufacturing information value, not on extracting data again and again. I'm going to skip this part because we're out of time. We have one more demo that helps, I hope helps cast a vision for that interoperability by layering in additional data sources that come from a different direction. So Rob, this is your cue. The clicker's broken again, so we'll just switch to your laptop.
Thank you. I was looking for a physical button. Good morning, everybody. Rob Schoentaler. I'm also with ThinkIQ and have a couple roles with CESMII. In addition to the technology relationship, I'm responsible for what we call the road shows. So I run a Smart Manufacturing Innovation Center that fits in suitcases and travels around the country. So we've worked with several of the MEPs and continue to do more of that. So a few different roles here. Let me share my screen and quickly. What I got, like 5 minutes, Jonathan? Order. Okay. What? It's like forever. Holy cow. Screen. All right. So quick tee up for the concept. So I'm going to cover a few things related to broadly getting unstructured data into the platform too. We've spent a lot of time talking about our favorite historical world of OT and tags and how to fit those to profiles. But, you know, it's 2024 and there's a lot of other types of data too. I think it's really important for any modern platforms to be able to deal with the unstructured as well as the structured. So I'm going to start with a little bit about vision is one of the sources that we're excited about and been using for a while. So when we think about helping manufacturers, ultimately, if manufacturing companies don't use any of this technology, it was kind of a big waste of time. I mean, let's be really realistic, right? So if I think about it through the lens of what Anderson needs to do, right? Like they're trying to manufacture better. We're helping not only on factory floors, but with overall supply chains. So we kind of deal with the physical world and we've got materials or ingredients that we're buying and we're using those to produce products that we sell. To do that, we have vehicles delivering those goods and then we use machines and equipment to kind of transform those into products we sell. And oh, by the way, there's people that work with it, right? So there's a whole physical world that we need to kind of have context for. And it's important if you're trying to be better at running your business to be able to get all the data you need. And one of the things that we've observed is if you just focus on connected things, you're going to have what we call blind spots. And this is an actual floor plan of a factory. Mid-sized manufacturer, pretty vertically integrated, discrete process. And in their plant, the only department that was kind of hyper automated and connected is this one little green square. It's a finishing area, really important for the product. They've invested a ton of money, right, in automation and process control. But if you're worried about overall throughput, there might be other things you care about, right? They have a bunch of modern equipment. Many of these blue shaded areas are CNC mills that they could plug a cord into or use one of the CESMII ecosystem partners to talk to them, but they haven't had the time or skill to do it. They're not kind of savvy in that. You got a lot of old equipment. I love this section down here. These are little punch presses from the 1950s that work fine. They're fully depreciated and produce parts. If you run a plant, that's a good thing, right? Jonathan said before, I don't want to go buy a new piece of equipment to get data. That's absurd. But it's important though. That might be a choke point, right? And then finally, what about the manual activities? And when you talk to the plant manager, That's the killer. So that's final assembly, high mix, complex stuff. The only data they had was how much they paid for payroll for the shift and how many units they made. And it wasn't enough units. So that's all they knew, right? Well, how do you start decomposing that and then not only get information on that, but then understand, the root cause is likely going to be something else that's feeding it, right? If I go back to the, what do you call it, the tool chain or the train, whatever that was, right? So we want to help manufacturers digitize and analyze the things that are important to them, not just the things that are easy to do. And so when we kind of look at the legacy equipment and manual activities, this is where sensors, Suellen showed us before the NCD sensor, right? Some of these things you can put a sensor on, it's great. But a lot of the manual stuff, we would argue that a camera is the best thing. It can watch and do its do. So that's part of what I'll talk about here is, well, how does this come to life? And the idea behind it is, we want, oops, come on, thing. So we want big data. Industry is driven by data. If you walk a factory floor or the shipping department, et cetera, you can see everything, right? We've set out the management systems on floors to be very visual in nature. So what if we could just see the data to fill in all those data gaps, right? So we've got a pretty sophisticated ability to use any camera and have it, whatever it sees, we can turn into data streams just as if they were coming off of a PLC. And then work with it all natively in the platform so it's not this other thing I have to manage. So I'll show some examples of it. I don't have too much time. So the first thing you'll see, and some of you have seen these at the road shows, and we'll have it set up this evening at the little event at 5 o'clock, what if you want to see some more. So we have a little tabletop demo we can do. And this is from yesterday before I left my house. But I'm seeing time series data here showed in a chart. But the nice thing is this is all actually coming from a camera. I can, if I want to, I can click through and see the raw source of where it came from. If I'm interested. The intent isn't you shouldn't have to look at a lot of stuff. But it's kind of nice when you're trying to say, can I trust the data if I want to understand it, to be able to go look at the provenance and see where it came from and not have to go somewhere else to interact with it. So in addition to producing data streams, we have a variety of things. This is reading a work order. So, when you think about going into manual activities, meeting the people where they are today, we have found cameras to be an incredibly valuable kind of horizontal sensor that can digitize just about anything. And when we talk to manufacturers and say, you don't need to change what people are doing, but let's give you data and analytics, it's really powerful, right? Because introducing new systems has the for people to use and get trained on has a high risk of adoption failure. If I don't need to do anything different, but get better at analytics and feedback, then that's even better. So great example of this, one of our partners, Full Bore, and I don't know if we've shown the video yet, but there's a great testimonial that CESMII did with this manufacturer, PTA Plastics. So this is a smart app that runs on top of the platform called Win the Hour. Was Studi here? I don't know if he's here. Oh, there he is in the back. Okay, great. So this is a feedback screen that shows the workers how they're doing by hour. The premise is if you don't hit the first hour, you're probably not going to hit the next one. You're going to miss the shift. How do I stay on track? So there's a screen giving real-time feedback to workers on a manual assembly line. But how does this data come in? Well, they're not typing in an SAP screen or something, right? The data is just getting produced for them. How? So I think I go here. Where's my model explorer? Sorry. All right. So what we're looking at here is they are making, it was funny because our safety briefing talked about the defibrillators. This company is Plastic Injection Molding Company, and they're making the cases for defibrillators. And it's a very simple line. Starts over there, goes this way just because of how the physical line is laid out. Something inserts a lens, a person runs a little piece of equipment. It goes through an anti-static, gets screen printed, manually placed, screen printed comes out, and then it goes through a dryer, right? This is the line. And we've digitized it by sticking cameras. This is data that comes off the line. Again, I'm putting it in this chart. I can see little indicators every time a part goes by, so we're counting the parts automatically. And then in the model, because we have interoperability, all we had to do was we've got a physical model of the line, and there's an object that we stuck underneath the dryer called the Full Bore manual assembly station object. And the Full Bore application just looks for those nodes in the graph and says, oh, I want data off those because that's what I use. And so you just had to drop it underneath. It doesn't matter how the model was done of the physical floor. Just by dropping that in, the Full Bore app is able to talk to the platform and produce those screens that the workers use to keep on track. And they've got great success story there. So a quick example of that. Under the covers too, we've got all sorts of tooling to, oh, is it, yeah. So, we've got native built-in tools to manage the camera system. We model the system of edge equipment in the platform and manage it there and do alarming and alerting. So kind of natively using to manage the equipment that you use to watch. So kind of an interesting application. And we've got some more fun stuff too. This is forklift safety we've been doing in some of our distribution customers where we can keep track and see if forklifts are getting too close to people while they're walking around. This is an automation of containers going over a scale, getting weighed. The system's able to keep track of, things moving through, and that this one was weighed here. It reads the container ID as it drives over. It's looking at a scale reading inside the scale house, chassis lights, knits it all together, produces events, and then messages that out to DCS control system saying this container is eligible to be filled, which they didn't have before. And also processes complete loads into, I think it's SAP, to say we've now completed this fill. So there's a variety of ways to use vision, but again, if we can see it, we can digitize it and we can produce it to be data just like it was coming off of a piece of connected equipment. So very, very powerful to have a kind of a simple, low-cost way to do that. And then the other thing I want to talk about in terms of unstructured, and we'll do tomorrow in the the demo fest, we'll show more of this, but the ability to work with unstructured data. So we've got, this is more of an AI model, not vision-based. Where am I going in my model? Sorry, chassis press. So tomorrow we'll show an example where we're helping a maintenance worker deal with troubleshooting this motor, and it's got a support bot embedded. I can ask it questions like, what serial number am I working with? And it uses is this motor, and I can't type. We'll see if it fixes it. Oh, it figured it out anyway. So that's looking at the graph of what motor I'm on. And then I can also say what might make the motor hot. Might make the motor too hot. And it's going to give me an answer, but what it's using as the source is the maintenance manual that was uploaded to the platform. Right? So it's interrogating the manual to try to help the worker get the work done faster. So we'll do kind of a pretty sophisticated workflow demo tomorrow of that. But again, unstructured data. I mean, it's text, but they're different. So pictures, videos, text, it's all the new world that we need to be able to process. Okay, thanks. Oh, there it is. Sorry. So.
I asked Rob to share that because what's important to call out there is while vision AI can be super sophisticated, if it's not attributable to the model, it gets lost. I don't have time for any more slides. We're going to do just a little bit of business. Go back on that one. A couple of presenters, I think, including myself, referred to Demo Fest. There is no session called Demo Fest. That was just our internal name. It's called Smart Manufacturing in Action. Please come to that if you can. The session today was built about a year ago and was built around ThinkIQ because they've helped us explore many of these ideas. What I'd really like to call out is that in the past year, more vendors have joined this ecosystem and are pursuing these ideas. So I see HiByte in the room. You're going to see HiByte tomorrow at Demo Fest. I see Inductive. You're going to see them at Demo Fest. HiveMQ is in there. Rockwell Automation is in the room. They're new members. SAS is in there. QuickBase is in there. So please come to see a fuller picture of an expanded ecosystem, kind of thinking along these ideas. How do we democratize access to this data by making sure it's type safe? Instance objects come from a definition. Those definitions are based on standards where applicable. Those instance objects belong to a graph. Their data may be augmented by these other sources, but it's always attributable to a graph. And that the software provides APIs that allows us to get access to those objects and their relationships. That last part is evolving, but these are folks that are working with us on it. There's more than 200 members now, so I haven't called out all of them. But please know that this is more than just a couple people in this room. There is a global effort to accomplish some of these things. All right. Some of you are at the Smart Manufacturing Executive Council. This is part of how we're trying to push these ideas to small and mediums, is by having the big manufacturers step up and say, this is what we want. So if you have SMEC on your badge, it's a little round bubble, that's Smart Manufacturing Executive Council. You probably already know if you're on it. Catch the bus now. For the rest, and you'll have lunch over there. For the rest, you'll have lunch out there or in the tents. Sometime after this, I think you get a little time to mix around. If you then want to go to the MDF tour, meet in the lobby. I gotta get that thing out of the way at 1 p.m. here. If you are at SMEC, you are not on this tour. You'll be offered a different tour. Okay. So those are the two kind of tracks. For everyone else, for everyone, there is a welcome reception tonight from 5 to 8 p.m. And there are shuttle buses for that as well. So if you are an exhibitor at that, there's a pickup at 2 p.m. A bus will take you so you can set up for the welcome reception. For everyone else, if you're just coming to the welcome reception, there's a bus coming at 4:30 that will take you there. 8 p.m. Return here. So at the end of the welcome reception, you can return here to pick up your car or Uber or however you want to get back to your hotel. And then there's another departure from main campus at 8:30. If you were exhibiting, you get a half hour to tear down. Okay, I know we covered like a ton of things, hopefully enough to level set everyone. There'll be more discussion about these things, and there are CESMII members with these little badges or shirts that would love to engage with you and talk about them more. We're finishing on time. Thank you, everyone.